second question.
All right.
So, first question is, are you familiar with the concept of order statistics? Have you heard that term before?
No.
Okay. It's a very simple thing with a overly complicated name. So, given a unordered set of numbers, like what I've written here, the order statistics are like the nth element in the list if it were sorted. So like the first smallest number in this list is going to be 1, and then the second smallest number is 2, and then basically the order, in terms of the order, the nth order statistic is then the nth smallest. That make sense?
Yeah.
I guess this is a bad set of numbers to have chosen. So then this makes it a little more clear.
Mm-hmm.
All right, so we're just going to have some algorithmic questions about finding some of these nth order statistics. And just to get started with sort of a warm-up problem, how about if you write a function that, given a list of numbers that are out of order, you just find the smallest. So basically the first order statistic.
Okay. Sounds good. So I'll just declare it here. Public static int is the return. And then I'll just call it min.
Yep.
And this takes int, I'll call it n. All right. So then here I'll
so then take in this will be like an array. Yeah.
Yeah. Sorry. Okay. You know what? Oh, okay. So then I'll loop through the array.
Mm-hmm.
And then for each of those iterations, I'll compare it against a min that I've already set up. So I'll set the min to be ARR at 0. And so what should I return if the array is null, or if there's no values?
Don't worry about that case. We'll just assume it always has some values in it.
Okay, sounds good. So then we'll set the min to the first one, and then going through if the, so then we can actually start, okay, yeah. So then going through to looping through the array, if the element at the index of I is less than min, then we make that the new min. And then at the very end of the for loop, you return min. Yep, so just to test it to make sure, I'll write a little test here.
Sounds good.
So input is equal to, let's see, so like 2, 3, 0, 6 should give us 0.
Yep, sounds
here,
good.
Min input. And let's try that then. I put it inside the for loop. Okay. All right, there we go. So it returns 0.
Perfect. And what's the runtime of this algorithm?
Oh, then.
And is there any faster way that you can do it?
For an unsorted array that I know of, no.
Correct. Okay. So now you definitely got the idea. Now let's make this a little harder, a little trickier. And how about you give me the second smallest number?
Okay. So for the second smallest number, then I think what we would need to do is maintain 2 variables and then kind of check across both of them to see like sort of like a larger min and a smaller min or something like that. So then we can check to see if there's a number that's smaller. If it's smaller than both of them, then we'll put it into the smaller min. And if it's only smaller than the larger one, then we can put it into the larger min, the new larger min. So once again, are we assuming that the array's length is 2 or greater?
Yep.
Okay. So then I'll just call this min 2. and we'll put this at the second element of the array. And then here, if the array is greater than the min, then it's the very smallest one. So the min becomes array at 1, and then min 2 becomes min. Well, we'll do this first. So then min 2 should be set to min, and then min is set to the new minimum. And then otherwise, if the array element is less than min 2, sorry. Okay, so if it's less than min 2, whereas it's still greater than min 1, then this means that this should be set to, so then min 2 becomes the new element, and then instead min becomes min 2.
Min 2 becomes the array. Wait, but what happened to min then?
Oh, sorry, yeah, this is maintained same, I think. Yeah, because if it's less than min 2, then min 1 is still the smallest, so then that should stay the same, but min 2 gets updated.
Okay, yeah, let's run this.
Oh, I have to return min 2 this time. Okay, so this one should give me 3. Oh, sorry, it should give me 2. Okay, there, give me 2.
Yep, perfect. Okay. Yeah, interesting. I'm trying to think if there is, I'm trying to see if there's a corner case here with the fact, does min 2, what if, yeah, I guess, what if these were the numbers here? I'm trying to think. Let's try those out. So the number, so it should actually be 3, because 3 is the second smallest.
Yeah, something 3.
And so min 2 gets set to, I guess I'm just looking at this. Oh, what if there were because you start back at 0 again, and then you flip it all around. I got it. Okay, yeah, perfect. Okay, and what's the runtime of this one?
This one is still open.
Okay, so let's just say that we're, as you might have guessed, we're going to want to move this and turn it into n. So we're going to want to add another parameter here that says I'm going to find the n smallest. Now, one way you could do it is you could just expand on this idea, and you could just create sort of a list of all of the mins up to n.
Right.
Now, what would the runtime of that algorithm be?
Well, if we're storing them all, then we need to check across each of them each time. So the runtime would become n squared, since we're running through all of the previous values every time we go through the array. Yep.
Okay. So to get the 0th, or the first, it just took O of 1 or O of n. To get 2, it took O of n. But now if you expand this in that same sort of pattern, it actually becomes O of n squared.